Hey everyone, welcome back to the channel. Today we are diving into object oriented programming, also called as OOPS in Python. If you have ever wondered what these words are like class, object, self, init, don't worry. By the end of this video, OOPS will make total sense to you. So let's go ahead and learn OOPS today. I'm going to break it down in the simplest way possible. So imagine you are creating a banking application. Now, for this banking application, we need to track multiple bank accounts. Now, each account will have a name associated with it, the name of the account holder. Then there would be PAN card, maybe, and balance. At least this much information we'll need. Now, if we have to do it, we have to create this banking application without using OOPS. How we would go about doing it? Pause the video for a second and think about how you would create a banking application without using the concept of oops with whatever we have learned so far. So what we can do is we can probably go ahead and create a list. Maybe the first element of the list could be the name of the account holder. So let's say account holder name is Aryan. Then the second digit could be the or the second element could be the PAN card. And the third element could be the balance. So balance is, let's say, $5,000 or rupees. Now imagine managing 100 different accounts this way. This balance can also change. A person can deposit the money, withdraw the money. A person can request for the change of PAN card number or contact number. So managing for 100 different accounts in this manner can become really difficult. How would you know which element represents what? What if you want to add more details? So right now the bank is just taking the name, the PAN card, and the balance. But what if later on they decide, okay, we need the email ID also of the person. We need a phone number as well and the address as well. So I'm not saying you cannot do it using whatever we have learned so far, but using the functional programming where you create functions and use these data types to manage all this information can become very confusing and it is very error prone also. So this lacks organization. A better way to do it is using object oriented programming. And that's what we are learning today in this class. So first, let's understand the concept of class. So what is a class in OOPS? So class basically has the blueprint or prototype from which objects are being created. Prototype from which objects are created. So to understand class, let's go back to the banking application example. So imagine you walk into a bank to open a new account. The bank gives you a blank form for you to fill. So the form would have, or the form would ask for details like your name, your PAN card, your number, your address, your initial deposit. So this blank form is nothing but like a class. It's a template that defines what information an account should have. You would not add information from your side here. Whatever the form is asking for, you will provide that information only. So you will refer to this template that the bank has provided you and fill in the information. So that's a class. Once you fill out the form with your details, so filled form with your details, it becomes a real bank account. It has real world data. And that's what we call object. Now, from this class, this form, bank would not just have one form specially for you. It would have got these multiple forms printed. So anyone who walks into the bank to open an account, they would hand over this blank form. That means from one class, multiple objects can be created. Multiple people can fill in their information and create an account. Now, this class that we have created will have some properties or characteristics. So properties are things like the name of the person opening the account, their address, maybe their PAN card number, the opening balance. All of these things are properties of the class that you have created. Let's just call that class bank account. So these are the properties. These properties are called as attributes. These properties are called as attributes. And then with the bank account that you have opened, you can do certain things or certain behaviors can be done. And this is called as the behavior or the things you can do. This is called as methods. That means a class would have some attributes and methods. So now let's go back to the definition written on the top. What does it say? The object-oriented programming is a method of structuring a program by bundling related properties and behaviors into individual object. So what are we saying here? That for the bank account, we are creating this class which is bundling everything, the properties, which we call attributes, and the methods, the things or behavior you can do on the bank account. And that is what object-oriented programming is. So the methods in case of a banking application would be things like you can do deposits. So maybe you have a method for deposit. You can do withdrawals. You can maybe update your mobile number, update your address. So all these things are your methods for the bank account class. So let's go ahead and create a class. So to create a class, we use the class keyword, which is followed by the name of the class. Generally, the name of the class starts with a capital letter, but this is not a rule. This is something that is good to follow. So bank account, I'm calling my class bank account. And then let's just create an empty class for now and let's run it. So I've created this class called bank account. Now let's create an object of this bank account class. Object, we can call it, or we can also call it instance. Same thing. You would see these terms being used synonymously. So you can either call it object or you can call it instance. So we can create an instance from this class. So let's say Aryan has come to open a bank account. Let's just say Aryan bank account and this. So this is how you create an object from a class, object or instance from, or let's just say of class bank account. And you can go ahead and create more such objects. So first let's check the type of this variable Aryan. What does this mean? That this Aryan here is an object of bank account class. Let me write that down. Aryan is object of bank account class. Let's just enclose it in print. So let's just use print to print this. And this is what we are getting. Now you can create multiple objects from this class. Class is just a blueprint from which you can create multiple objects. So let's say another person goes in, name is Ram, and he also opens an account. So Ram once again is an object of bank account class. Let's check. Now let's add some attributes to our bank account class. Right now it's just an empty class. We are not doing much here. So maybe I want to add the account holder name, maybe the PAN card number, the balance. The property that every bank account must have are defined inside the init method. So this is a special method. It's actually underscore, 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 underscore. When I say method, any function which is written inside of the class, we call it method. Method is nothing but function written inside a class. So let's say we want each bank account to have a name, address, a balance. So we have to set up all these attributes inside this underscore, underscore, init, underscore, underscore method or function. So let's do it. You know how to create a function. You use the def keyword. The name of the method has to be this. It cannot be anything else. And then I'll write self here. So every method inside a class has first argument as self. Every method inside a class or every function inside a class has first argument. The first input, the first parameter is always self. Now, what is this self? Just hold on to that thought. We'll come back and check what is this self. But every method has to have the first argument as self. So I'll say self, and we have to give this as an input to this init function, the name and the balance. So that has to come as an input. So we'll say, uh, let's just say name of the account holder. Maybe we have the PAN card number and we have the balance. And then inside of this function, we'll say self. I'll come back to this self, but let's just go ahead and run this first. And let's create a variable called as account holder. And I'll give it the value name, then self dot PAN card. This will have the value PAN card, and self dot balance is equal to balance. So first, let's go ahead and run it so that it becomes clear as to what we are doing. So now let me run this line as it is. What do you think will happen? It will give me an error. What does the error says? The error says that this init function missing 3 required positional arguments: the name, the PAN card, and balance. But you might say, hey, we never called this function. Why is it even talking about this function here? We were just creating an object of this bank account class. So why this is mentioning this function here is because whenever we create an object of a class, the init method is implicitly called. So whenever we write this line down, the init method gets called. So you don't have to explicitly call it. Whenever you create an object or an instance of a class, this init method gets called. Okay. So yes, this init method is getting called. Now, how many arguments do you think this init method is taking? It's taking 4 arguments, you would say, because self is 1, name is 1, PAN underscore card is 1, and balance is 1. But we don't explicitly pass the value for the self. What is this self but? We'll come to that. But for now, just take a note that we don't pass the value for self. It is not passed explicitly. Internally, it gets passed, but you don't have to explicitly pass the value for self. So that means we have to pass name, PAN card, and balance. So let's say the name of the account holder is Aryan. PAN card is just some random string here. And balance is, let's say, 0 or 50. So we have created an object of this bank account class, as you can see. Now, what is this account holder, PAN card, and balance here? These are our attributes. Now, these attributes, the name, PAN card, and balance, are called as instance attribute. Instance is what? Object. Why are we calling it instance attribute? Because they belong to specific instance of a class. Belong to specific instance of a class. That means when we say account holder, right, for Aryan object, it will have the name Aryan. If I create another object, it would have the name of some different account holder, some different PAN card it would have. So these attributes, these values are specific to a particular instance or object. That is why they are called as instance attribute. Now, if I want to check the value so I have this object Aryan and I want to know what is the balance in Aryan account. So how do we access this attribute? We use the dot operator followed by the attribute name. So 50. Let's create another object here, Ram, and name is Ram. Okay. And some value here and some amount. Now, if I check the balance for Ram, how would I check the balance for Ram? The object followed by dot followed by the attribute name. If you check the account holder, it's Ram. If you check the balance, that's 100. You don't have to put parenthesis after this. This is an attribute. This is not a function. So to access the attribute, the object name followed by dot, then the attribute name. But what's going on with this self here? So as I said, the first argument of every class method, a function inside a class, is always self. But what is self? So self is, just put it down here. Self is reference to the current instance of the class. So self is like we are pointing that we are talking about this customer. We are talking about Aryan. We are talking about Ram. It's like raising our hand and pointing to a particular object. So that is what self is doing. So why don't we have to, you know, pass a value for self here? Because self is implicitly passed argument, right? This parameter named self, this is implicitly passed and it refers to the instance through which this method is invoked, which simply means when I say Aryan is equal to bank account, so I'm creating an object for Aryan. So self here will automatically point to Aryan. When I say Aryan dot balance, this will give me the balance for this Aryan object. Self is just a reference. It's a pointer. It's like a pointer to a particular object. And because we are using the object name here, we don't have to pass explicitly the value of self. Internally that gets passed. So a quick recap at this point. To create a class, you use the class keyword followed by the name that you want to give to your class followed by colon. A class has attributes and methods. To create instance attributes, you have to use this particular method, the underscore underscore init underscore underscore. The name has to be exactly same. This is a special method. This behaves like a constructor with this in Java and C++. So this is a special method which automatically gets called whenever we create an object of this bank account class. And then we are saying that we have these instance attributes which are very specific to each object, the name, the PAN card, the balance. And then we are saying self.account holder. Why are we saying self.account holder? Because we are saying for Aryan, what is the name of the account holder? For Aryan object, what is the name? Self has that information about the current object that we are talking about. Similarly, self.PAN card. What is the PAN card of this Aryan object? Which object are we talking about? Aryan. When I say Aryan.PAN card, it gives me the PAN card of Aryan. Because the self has that information that this attribute is fetched for Aryan object. We are pointing to Aryan. We want his PAN card, not Ram's PAN card. That is what self is doing here. So I hope this is clear. Once again, all bank account holders would have a name, a PAN card number, a balance, but the actual values will be different for each account. So that's why they are instance attributes, and this is how you define instance attribute or provide the value or set up the initial details for your instance attributes by using this init function. Now we also have class attributes. So some attributes remain same for all instances of the class. For example, all accounts belong to the same bank. So We can define such attributes outside of the init. If you know that, okay, a particular variable would be same across instances, across customers, you can define it outside of init and then it becomes class attribute. Remains same for all instances of a class. So let's say we create a variable with the name bank underscore name. And let's say the bank name is XYZ Bank. So this is a class attribute. Bank underscore name is a class attribute. You don't need a self before it, self dot bank underscore name. Why don't we have self dot bank underscore name? Because this is same across all the objects. You don't have to specify which object you're talking about. Irrespective of the object, this will remain same. The bank name would be XYZ Bank. Okay, so how do we access the class attribute? So for Aryan here, I want to access the class attribute. So I'll say Aryan dot bank underscore name. And it's giving us XYZ Bank. So we have talked about attributes. But I told you a class is attributes and behaviors, things to do. You open the account, but once you have opened the account, you want to do certain things. Maybe withdraw money, maybe deposit money, maybe update your mobile number, maybe check your bank balance. So that's where methods come into picture. So you can basically think of methods as functions acting on an object that take the object itself into account through its self argument. So let's try it out. So let's say I want to create a function or a method for depositing the money. We will say def, let's call our function deposit. Don't forget that self is the first argument always because we want to know who is calling deposit, which account holder or which object is calling deposit. So that information we are passing through this self argument. Who is calling? And then the amount will be an input to this function, the amount the user wants to deposit. And we can check if amount is greater than 0. We can go ahead and increase the balance, add the amount to the balance because he's depositing the money. So this gets added. We'll update our balance amount. This would be amount. And if you want, you can go ahead and print this much amount deposited. Updated balance is the dot balance. Else you can print deposit amount must be a positive number or greater than 0. So let's go ahead and run it. So I have this Aryan who has an account with my bank and now he wants to deposit some money. So how do we call this function? Previously, we have seen to call a function, we just have to give the name of the function followed by the parenthesis. Let's say 30. Will this work? The answer is no. We are getting name error. That means this deposit function is not recognized. Why? Because this is inside a class. This is not your normal function. This is inside a class. How to call a function which is written inside a class. For that, we use the object name. Here, Rn is the object, followed by dot, followed by the function or the method name. And here, this function takes one input, 30. The self value is anyways passed through this because we are saying Rn dot deposit. So it knows that we are referring to the Rn here. So this gets implicitly or internally passed. RN is depositing $30 and his updated balance is $20, $80. So now if we go ahead and check what is the balance of RN, so we can say RN dot balance and 80 is the new updated balance. And we could do the same thing for Ram here also. We can go ahead and deposit some amount. I need to run this again. And let's say Ram is depositing $100. Under deposited, updated balance is this. Let's just check the balance now for Ram, and this is 200. Similarly, we can write a function or a method to withdraw the money, self, and the amount a person wants to withdraw, colon, if amount is greater than balance. So a person cannot withdraw more than he has in his account, of course. And then we can just go ahead and print insufficient balance. Maybe you can show him how much fund he has. Else, withdraw the money, update the balance, self dot balance. And we can print also that this much is withdrawn and this is the updated balance. So this much amount withdrawn, updated balance is this. So now if RN here goes ahead and withdraws some money, his updated balance was 80 the last time we checked. So now he wants to withdraw some money, so he can just withdraw maybe $30 or $20. You need to run this class again, these changes to reflect back. Now this is fine. So now if you check his balance, it is 60. Now, a couple of things to note here. Why we are not saying self dot amount? Because we don't want the amount to be a property of this account. A person can go ahead and deposit multiple, he can do multiple transactions. And this amount value would keep on updating accordingly. But if you want to save this last amount withdrawn or deposited, you can go ahead and make it a attribute by using self here. So you can make it self dot amount is equal to whatever value. But let's say you want to save the transaction history of the person, then you can create another attribute here called transaction history. And this would have the opening balance because this balance is nothing but the self dot balance here is nothing but the opening balance. We can say self dot balance or balance is also fine because it holds the same value. We're assigning the self dot balance as value balance here. And then we can keep appending this transaction history. We can do something like this self dot transaction history dot append, and we can just append the new amount. So positive amount in case of deposit, and for withdraw, we can say self dot transaction history and maybe make it minus. And now Aryan opened the account with $50 and then he deposited 30, then balance is 80, withdrawn 20, balance is 60. But if you want to check the transaction history, you can see, say, RN dot transaction history. This is the instance which will hold that value. Started off with 50, then plus 30, and then minus 20. These are all the transactions that he has done. So yeah, you should not just go ahead and make any variable your instance variable. Instance variable are more like characteristics or properties. So if you're using a variable one time, it gets updated. That doesn't have to be an instance variable. But transaction history here makes a good instance variable because, or instance attribute. Why? Because you would want to have the entire transaction associated with a particular bank account saved somewhere. So that's on Oops, everyone, for this video. One more thing to note here is that everything in Python is a class or is an object. Everything in Python is an object. Why do I say that? That everything in Python is an object. This is so important. Let's just write it down. Do you remember in the previous lectures, we were using type to check the type of a variable? So we would do something like this. Let's say we create a variable a is equal to 1, and then I'll go ahead and check the type of this variable a. Let's just print here. And that time I didn't tell you, but now I think it should be very clear to you that a is nothing but an object of class int. So there is a class called int, just like the class bank account we have created. There's a class called int, and that has some attributes and methods. So let's try another one. Let's create a string. Hello. When I check the type of this variable b or the string hello, it's a string data type. So what is b? B is, or hello here is, object of class string. There's a class called string somewhere, str, which has all these attributes and methods. So you remember when we were calling any method or function for string data type, we would do b dot, let's say we want to make this uppercase. Like this, we would call a function. So this upper is nothing but a method written inside the class string. And how do we call a method which is written inside a class? How do we call a class method? We use the object name. So here B is the object of the class string dot the method name. So lower. So while we were calling a function, if there is a function, let's say greetings, and it was just printing hello world. To call this function, we will just give the function name and whatever input this function takes, called greeting. But why were we calling this lower function differently? We were saying the variable name followed by dot, followed by the function name, because this lower is a function which is written inside a class called string. So we were creating an object of this string class. When we say b is equal to hello, what are we doing? We are creating an instance or object of string class. And then here we are calling a method or a function which is inside the string class using the object name followed by dot, followed by the method name. The same thing we were doing here also. To call deposit function, we were giving the object name followed by dot, followed by the function name. So that is the reason I said everything is object in Python. Now, this doesn't mean that every problem under the sun you would just go ahead and apply OOPS. Not every problem qualifies for OOPS. Some problems are easier solved or better solved using functional programming, writing simple functions, or just writing the code directly. So it's not that this is the approach for everything, but yes, for many problems, especially for real world problems, this works beautifully. So we covered classes, we covered objects, we covered attributes and methods, and we saw how they help us build an organized, reusable, and scalable program. This banking problem without OOPS, it looked quite confusing to implement it, can be done, but very confusing. A lot of things we need to take care, but with OOPS, it's very simple. I mean, just wrote our banking application. But wait, there's much more. In the next video, we'll dive deeper into properties of classes. So there are things like private variables, getters and setters. You have inheritance, polymorphism. So stay tuned, everyone. If you found this helpful, drop a like, share your thoughts in the comments, and try building your own bank account class with extra features. Like you can create an interest calculator, or you can go ahead and create a function to check the bank balance, to update the PAN card or mobile number. So try it out. Hope you enjoyed this session. See you in the next one.